Welcome back to Carter Engineering Fabrication. I'm Chad, and this week I've got a fun one. So I'm getting started in the first part of what I think is going to be a multi-part series on a weld positioner. Needed one for several years now. I'm finally getting around to it. I've got a nice collection of parts to go over. I've been busy with a lot of stuff in the shop, including the Bonneville, so a little teaser on that, but got a little behind on the video, so let's get caught back up. This is the setup. Let me get my bearings a little bit here. So 12 volt DC power supply coming into the PWM controller. So right now, just reading 0. That should vary. I need to figure out a way so we can get that clamped in place so we can see it. Yeah, okay. So we've got toggle switch, off, left, and right, so bi-directional. We've got potentiometer with the digital readout. It's pretty inexpensive Amazon kit, right? So 12 volt PWM controller. I've got a latching push button switch. Latching push button, meaning push to on, stays on. Push again. Without unhooking it, it comes off. The heart of this is a 12 volt gear motor, so 80-ish to 1 reduction. It's got the gear here, and I actually have a CAD model for this, so that's going to be super helpful, as well as a pigtail. So, power supply, PWM, electric motor. The star of the show is a 3-jaw chuck. I should get a measurement on that one. Yeah, so that's an 8-inch 3-jaw chuck. Pretty girthy unit, needs a little cleaning, but yeah, should clean up okay for a welding positioner. So, also has reversible jaws in case we needed to clamp something pretty big. And then we've got some bearings to pick from. These are all, most of this is auction find or Amazon, right? So auction find on the 3-jaw chuck. And then we've got some big ball bearings, open and sealed on one side. So my hope is we can print some kind of housing. And I've got a set of brushes here. So welding current, I'd like to keep the 12 volt stuff isolated from the chuck and the housing. And then these are like golf cart brushes. So we'll have to make some kind of holder that holds the brushes. Anyway, should be fun. Let's time lapse me getting some basic dimensions of this stuff and kind of talk through how I handle the gear. And we'll go through and start making a CAD model. Can't quite decide if this is 3 pieces or 2 pieces. Looks like this was the registration collar, and then this got turned down. threaded on the machine, so it looks like maybe it was on 2 different machines in its life, but could always machine the back of this down if we need to, or I can drill and add my own features to it. It's okay, let's carry on. Welcome. Let's get started. Go ahead and pop a new part in here. I think we're going to start with the chuck. Do a quick revolve feature. Really not sure if this is going to become a time lapse or how interesting this is going to be. Quarter, 8-inch diameter. I wanted 4.75 on the registration. Again, a couple of these are just tape measure measurements. We don't have to get too excited just yet. If there's any fits that need to be come back and be checked, we'll mic them or what have you. All right, let's get the menus on screen so you can see those too. And that looks kind of like a chuck. Let's throw something fun in here just to... There we go. All right, quick and dirty, we have a vise. So let's make a folder for this gem. Let's go ahead and get this part saved. Call this 8-inch chuck. Got a folder made up, so let's press on. Dirty bodies for the bearings. So I'm just going to do ODID. Cool. So this is our first bearing. This is the tiny one, the 6211 LU bearing. Go ahead and do a save as. We could do a configuration, but I think for this one we'll just save it as a separate part. And then adjust this file. Adjust this file. This is the larger bearing. Update, save. Okay, so we got the bearings. Go ahead and do the brushes while we're in here. Yeah, so these brushes are from a golf cart, so they can handle high amperage and they're also pretty inexpensive. So win-win. Cool. Let's throw a color on that one just for funsies. All right, so we'll call this one brush. Cool. What do we have left? Now we have the PWM. I will want to do that. Looking at my sketches here of the housing, and I wonder if it's of any value to model that. I'll just do the main block for a moment so we have a part to move around. We gotta I'll be right back. I didn't grab the dimensions for this. All right, we're back. So anyway, let's get a part roughed out for this just to have something. All right. Doesn't have to be pretty. Okay. So aside from the buttons and switches, we have the major components. Let me dig for the motor model, see if I can find that somewhere. Found it. It was buried in my files. So we have the complete motor assembly with the gear. It's a 10-tooth unknown details gear. So we're gonna fake it. I'm gonna go to my favorite place on the internet, McMaster, and we're gonna find two gears that are close. Thankfully, we're not buying them because they are expensive. But what we are doing is we're going to download the CAD models for them. Download. Now, observe closely, you'll notice that this is a 12-tooth gear. We need a 10-tooth gear. So let's see how difficult that's going to be to change. Is it going to be this easy? Maybe. Okay, cool. Let's turn off this. We actually don't need the center bore. Do we need center bore? Let's throw one in there. Let's throw a center bore in just to have something. And how big are we? Pretty big. Surface, smooth face. All right, so now we have a gear. Okay. That is about 3/4 of an inch in diameter. So let's go back to our assembly and let's try to figure out 857 is what that's measuring. If we look down in the lower right, anytime you do a measurement in SolidWorks, it'll show you some information out here without even having to go into the measure tool. So I'm just doing a quick point to point, 857. So we're gonna come in here and dial this just a little bit. So we need to go up 14%. So insert features, we're gonna scale this guy up. This is what I meant by cheating because we don't care what it is as long as we can mesh with it. So we're gonna say this guy. All right. Let's make a new assembly real quick and So if you're looking at what I'm looking at, it's not perfect. It's a little strange that the teeth aren't lining up. Why is that? Are my axes not right? Something's strange, and I'm not sure I can put my finger on it. If we're up here, we look to be reasonably well centered. So the geometry's close, and I can put enough slop in this mechanism to make it work, so we're going to proceed. And we are going to go back in here, edit sketch. So our pitch diameter is 0.625. We're going to add 14% to that. 4 times 0.625, 0.7125. So we're going to write that down separately. That's going to be our new pitch diameter. That'll be necessary when we go to line up the axes. So we've done our small gear. Now let's jump over to our big gear. So ideally, I think I'd like about a 10-to-1 gear reduction. I believe the free speed on that motor is about 80 RPMs. I'd like, at the very maximum, the weld positioner to spin. I mean, 8 RPMs would be pretty fast, but if you're doing a small part, and then with the PWM, we can dial that way down. So let's see if we can't figure out how to get this guy to give me, let's see, what am I trying to do? Okay, let's start with the hard part first. So we're going to try and adjust this guy to 100 teeth. Everything should be based on the gear pitch and then the number of teeth. So like the previous gear, this should update. And it does, and that looks pretty cool. Okay. I need that fillet to go away. So we're going to suppress that guy. Awesome. Okay. Insert face, delete. We're going to go ahead and delete these two faces. Now we're going to scale it up. So, just like before, we're going to note what the pitch diameter is, 6.25. So 6.25 times 1.14. 7 1/8, and as expected, that is exactly 10 times the amount that we wrote down a few minutes ago. So this is looking like it's going to work. We're going to go ahead and scale this gem up to its big size. Cool. And let's go back to here for a second. We're going to go ahead and set the thickness of this gear to match. So we are at 855, we want to go to 3.5. So we're going to move that face to 505. And that leaves us with the correct gear. So alright, we're doing good. We've got 2 gears defined. We can start a broader layout. So, we want to build this. Let's start simple with a big rectangular plate. So this will be our motor axis, or rather our chuck axis. Let's assume that the chuck is centered this way. And we've got an 8-inch chuck. Cool. Put a 5-inch hole through this, and alright, we can adjust all this later. This is just getting us a starting point. Now, we know that the 2 pitch radiuses, which would be 7.125 plus 0.7125 times 0.5, parentheses matter, 0.5 times 7.125 plus 0.7125. How much clearance should we add in there? Just a little slop is fine, right? Let's add 8 thousandths. You know what? No, let's just leave it nominal. We'll slot the holes so that we can adjust the backlash. Let's do that. That's a better approach. So, that's where the motor wants to be. Which side do we want the motor on? Let's put the motor on the right side. So the motor will be over here somewhere. No, this is critical. This is just getting us a starting point so that we can lay out some files. How long has this been recording? Ooh, 10 minutes, okay. Alright, we're gonna call this the sheet metal housing. Back here, float that guy. No reason this can't just become our main assembly. Insert components. Housing. Alright. Let's go ahead and lock that guy down to its home. Alright, I think I'm going to speed up the next bit. So I'm going to get an assembly roughed out and then Alright, welcome back. So let's take a quick peek at where we are and kind of talk about our next steps, because I think we might have to call it on this one. So what do we have? We have the chuck, we have the bearing located on the front, so the main bearing. We have the secondary bearing shown in green here, so like the tail bearing, if you will. A retainer on that bolts into the rear plate. So the main plate, probably do something similar on the front to collect the front bearing, and then that'll sandwich it between everything. The brushes are roughly laid in here, so that needs windowed, and then some kind of housing to apply a light pressure on those. The gear looks pretty decent. We can actually come in here, and the gear mesh, we've got pretty nice and neat. Why is that coloring? Refresh. There we go. Alright, so we've got the gear mesh. I can probably go in and loosen up the fit just a little bit. Actually, I might just go and do that now. This is probably going to be unhappy, but let's see. We can add a little bit. Yeah, probably be plenty good for the slow speed, low torque situation. So, what do we have? Really, the only thing that I'm disliking about this assembly so far is the amount of open space I have here on the sides. And I think that just means that I'm gonna have to make some like closeout panels for this to seal this up a little better. I'm a little undecided. I think this is gonna get a pretty large housing on the top that'll have all the buttons and things collected. As long as we keep it below this face, I think that'll be okay. Might add a means for a steady rest. I'm actually not mad if this thing has some exposed stuff. Maybe we just try to do a good job protecting the gear so you don't accidentally, stuff your fingers into it. But yeah, I think that's good for this. We put a bow on it. I knew this was a long one, but I had a lot to say and a lot to share, as is really my zone, and I enjoyed the design on this. So I'm really looking forward to bringing this one to life, get some of the laser cut bits on order, get some parts on the printer. Hopefully come in, I don't think I'll be able to make a big update on it in this coming week, but maybe in 2 weeks I'll have quite a bit to share on the weld positioner. I think it's going to come out really well. I think it's going to come out really well. I think it's going to be really cool. I'm excited. Please stick around if you'd like to see this one come to life. Thanks, and I'll see you guys later.